Our primary focus in this video is going to be dealing with conversions, and in particular conversions of different unit systems, primarily between the American system and the SI system. The biggest kind of point to get across is that all measurement systems are human inventions, and we use those human inventions or definitions to help us observe and measure the world around us. The biggest thing that we need to get out of this is that we're looking at four primary categories: length, mass, volume, and time, and that they have standard units associated with them. Those standard units are then shown according to our textbook as the basic units. Okay? And then they also have their abbreviations. For my sake, I prefer to not call them the basic unit, but I prefer to call them the core unit, because as a core, or potentially even a root, we can then alter that core by putting, say, a prefix in it. And so instead of having meters, I could have millimeters by simply putting that lowercase m in it. That does mean I need to know what these prefixes are, and that's where we get into our Greek prefixes, or Greek and Latin prefixes, depending at which scale we're at. And this is where I would recommend that you memorize what these ones in red boxes mean. So K is kilo, which means 10 to the third. Centi is 10 to the second. Sorry, let's not screw that up. 10 to the negative second. And milli is 10 to the negative third. Those prefixes should be memorized exactly as is. The rest of them, if you need them, will be given to you. But for the most part, we don't use, because those scales are either too large or too small for us to really work with at this level in chemistry or science. So, setting up some conversions. So I would like you to take a second here, pause the video, and attempt to solve this question. No, really, you should pause the video now. Hopefully you've got some work set up for this. So our general format for solving is step one, write down what you want. Okay? And in this case, I want the grams of the aspirin tablet. So some things to note: notice that we have a gram abbreviated, which is our measurement. That doesn't look remotely clear, so let's try that again. We have our measurement followed by our substance. Okay, it is important that we always specify these things. Okay, we need the measurement and we need the substance. Okay, the substance isn't as important right now in the semester, but it will become much more so important. On the left-hand side is step two. We'll write down what we're given. Well, what we're given is milligrams. Note that what the first thing I'm writing is the unit of my measurement, okay, and in particular milligrams of aspirin, and I'm given 325 of them. Okay, so again, I have the number, I have the measurement unit, and I have the substance unit. When we're trying to set this up, or this whole process is really a game of balance, okay, where our equals is in the middle. And what I have at the end, on my right-hand side, is exactly what I want, grams of aspirin, and I need to do something on the left-hand side, over here, to make sure that this balances out correctly. Okay, that's the whole point of a conversion process. That's what these equalities are. So, multiple things I've got to look at in this conversion. Okay, the number is ultimately my answer, but how I get that number becomes the important part. To get that number, I have to make sure that the measurement and the substance are the same on both sides of the equation. And so when I go through and look at the left-hand side of the equation, I may have the substance perfect, so that's good, but my measurement unit is not correct, so that's bad. So what I need to do is introduce a conversion. Okay, so I'm going to multiply by something that allows me to do this conversion. Okay, in that, I know that milligrams does not appear on the right-hand side of the equation. So I want milligrams of aspirin to show up in the denominator of this magical box to help balance these things out. Okay? Because if I place it there, those units would cancel each other. And it would disappear from the left-hand side, making it equal the right-hand side, or helping it to equal the right-hand side. I also know that whatever's in this box will hopefully have grams of aspirin in the numerator. Okay, that would be the ideal circumstance, because then what happens? The milligrams would cancel and I'd get grams left over as a unit on the left-hand side, which is exactly what I want on the right-hand side, so it would work. Okay? Now that I have a conversion, okay, the units that I want to use, now I have to ask myself, do I know that conversion factor? If I know it, I can merely substitute in the numbers according to the units that I've placed. If I don't know it, then I either have to look it up in the textbook or on the front of the exam, or raise your hand during an exam and be like, you didn't give me this conversion factor. Okay? If I'm being appropriate, I would then go through and say, well, you're supposed to know that, or I'm sorry, I should have given that to you and I'll supply it. Okay? So in this case, we just had a slide that said you had to memorize what milli meant. Okay? Well, milli, as a lowercase m, meant 10 to the negative 3. In this conversion setup, that milli, or that power of 10, needs to go with the core unit. Well, the core unit, or the root unit, is grams. So we would write 10 to the minus 3. Okay, we know it has to go up there because what did we say milli was? Milli is the same thing as 10 to the minus 3. So those units would, or those numbers, if you will, would theoretically cancel and we'd be multiplying by 1, which is what I'm allowed to do. Okay? So what number shows up in the denominator? Well, that number can't alter the 10 to the minus 3. Okay, so that number, it can be really anything, but whatever that anything is, can't change the value in front of grams. If I put a 2 down here, does that change that value? Well, now it's not 10 to the minus 3, it's half of 10 to the minus 3. Okay, so the number 2 changes the value, so that doesn't work. Okay? If I put 0, I'd be dividing by 0. That's not a good thing to do either. So really the only thing that it can be without changing the value is 1. Okay? Now that I have my units set up to do my equation, I recognize that I just need to multiply 325 by 10 to the minus 3, and I would get my answer. Okay? How that then gets reported, be it in scientific notation or in just decimal notation, is kind of irrelevant for this. As far as an exam goes, it would be important. Okay, so we could go through and look at this. We could end up with the option of 325 times 10 to the minus 3, 3.25 times 10 to the minus 1, or 320, did it again, 0.325. Okay, all three of those are equivalent but are answering different things. Okay, the 325 times 10 to the minus 3 is arguably never going to be correct. Okay, more than likely you would expect the question to either say what is the mass in grams and it be given directly as a decimal format. You may also hear what is the mass in scientific notation. If it's being asked for scientific notation, we have to provide this one. Okay, so that one's our scientific notation. So be careful about what's being asked of you when you go through and set this up. This was a relatively simple calculation. It was only one step. The point of this is not to make you do a bunch of extra work for a simple calculation. The point of this is to get you used to doing this work so that when we move to a more complicated calculation, you trust a process that'll get you to the correct answer. If you don't trust the process, you'll be dead in the water when we shift to a more difficult conversion. Okay? To that end, here's another example go through and again pause the video and try and come up with a way to solve that bottom question. And again, no, seriously, pause the video. Step 1, write down that equal sign to the extreme right of your page. Step 2, write down the units that you want for your final answer. Step 3, write down the units that you're given to start the calculation, followed by the number associated with it. Step 4, write down the units to get your conversion, ideally as quickly as possible. This is an interesting one because we don't know the conversion between milligrams and micrograms. Okay? So that means what we're going to have to do is convert, our milligrams to something else. I would make the argument that we can go to grams of aspirin. Do I know that conversion factor? Yes, that's what I'm required to know. Milli is 10 to the minus 3. The power of 10 always goes with the core unit. 1 goes in the denominator. Step 5 on. Come up with the next conversion to try and get you closer to your answer. In this case, we can go from grams to micrograms. I know micro is 10 to the minus 6. I did write that in after the fact. Okay, the power of 10 always goes with the core unit. The core unit is grams. And we now have our fully fledged setup of our calculation, and we could go through to determine what our actual numeric answer was. The process of doing that, take everything on top, multiply it out, so we get 25 times 10 to the minus 3. My calculator spits out an answer saying that is 0.0325. Okay. And then I will divide by 1 times 10 to the minus 6, which is 10 to the minus 6 here. And now I can divide in the calculator 0.325 by 10 to the minus 6, and I get my answer. Okay? So take advantage of each of those steps, writing each of those steps of work out. Okay? It becomes important to do this, and we'll see why it becomes important as we move through. A simple mistake can lead to drastic repercussions of wrong answers. Okay? So, advancing on, is everything going to be metric? So, in that previous example, or these previous examples, we looked at metric conversions. And this is where you'll hear people talking about King Henry dying on cups of coffee or chocolate. And while that's all fantastic and just shifting a decimal point, you have to memorize how to shift the decimal point, and that becomes more work. If you just go through and memorize what the powers of 10 are that you end up using, you don't have to worry about shifting decimal points or moving left or right or any of the above. If you do that well, phenomenal, great. You now have a way to do metric conversions. Not everything is metric, which means you're going to have to learn the process I'm telling you to do anyway. So if you just learn the process I'm telling you to do, you don't have to worry about this quite as badly. So, when we move out of the metric system, now you have to worry about odd conversions, and you have to look up those conversion factors. Okay? We'll address something as kind of an interesting feature when we look at this next question. Okay? So, as our practice, we want to go through and set up this conversion. The length of an American football field, including the end zones, is 120 yards. What is the length in centimeters? Okay? Yards is a American measurement, centimeters is a metric measurement, which means we will have to do an English metric conversion. This is where things can go potentially haywire if we aren't very, very careful in how we set up our process. So again, I'm going to recommend that you pause the video and try and set up some work. We will actually look at 2 methods for solving it in just a couple seconds. We'll actually go through and look at solving it out together in one method, okay, or one version of the method. So starting off, I want an equals. Okay, what am I trying to solve for? I'm looking for centimeters. Okay, officially I'm looking for a football field. I could go through and add the double F for football field. The substance isn't changing in the course of this conversion, so I could get lazy and delete the substance. Because the substance doesn't change, I'm allowed to do that. The measurement I start with is 120 yards. Okay. Well, yards is not the same thing as centimeters, so just as before, we're trying to balance this out to make sure the units are equivalent on both sides of that equal sign. Okay. That's our fulcrum, and we're trying to balance these things out. Okay. So again, take a minute, see where you can go from this. If you can, please pause the video. Are you getting the idea that you should pause the video yet? Because you should probably click that pause button. Okay, hopefully you have an answer, and maybe it looks something along these lines. We go through to set up our conversion. Yards, ideally I would jump straight to centimeters. Is that a conversion factor that I have? Well, I can look anywhere on this page for that conversion factor, and you'll notice that I don't have yards to centimeters. So instead, I'm going to go yards to feet. Why would I go to feet? Well, right above that, at least in my screen, I have a conversion factor between yards and feet. So I'm going to say 1 yard is 3 feet. Okay? Work students commonly make a mistake because they go through and say, well, I just need to divide by 3. Well, dividing by 3 isn't what you need to do here. You have to multiply by 3. Okay? So really the placement of that number, 3, in either the numerator or a denominator, turns out to be a 50% chance of getting it right. If it's only one conversion, 50% chance isn't that bad, and odds are that you're probably getting that 50% chance right in your homework. So you think you're doing this correctly. Then you get to the exam and you find out, based off of the odds, that the 50% that you need to get wrong ends up happening on the exam, and you end up bombing the exam. Let's say it just worked out perfectly anyway and you got half the questions right on the exam. That's still a failing grade. Okay? We need to improve those odds. That's the point of this process. Follow the process of dealing with the units. Feet is not the same thing as centimeters, so again I need to do another conversion factor, feet to centimeters. Okay? That's again a conversion factor I don't know. If I don't know the conversion factor, I'm going to have to convert to something else. Okay? I'm going to convert feet into inches. Why might I do feet into inches? Well, again, the conversion factor is directly above. Okay? Maybe somebody is leading me to help me figure this out. Notice again, this is again the placement of the 12. Does the 12 go in the numerator or the denominator? A common mistake is to not really know where it's going and arbitrarily putting it in. So again, we have a 50% chance of you successfully doing this correctly. 2 50% chance questions lined up next to each other drops your odds of getting the question correct to 25%. This is a horrible exam score. You need to follow the process. Okay? Next step. Inches is not centimeters. So I will write inches below, and I want centimeters on top. Again, why? I want the inches to cancel, and I want centimeters in the numerator because centimeters is in the numerator in my answer. Do I know this conversion factor? Well, the conversion given directly above me is yard to meters. Well, why would we do that? Okay. The conversion I want is actually all the way up to the top where I have inches to centimeters. And in that I know that there's 2.54 centimeters in 1 inch. Again, this is a 50% chance of placing that 2.54 in the correct spot, and your odds of getting this question correct drop below or drop into, what is that, 12.5% chance. Okay? Those odds are horrendous. Okay? I don't want you to be in that situation. That's why you need to spend your time working these questions, solving according to the process, not according to just, well, I multiply or divide, or that's what the calculator tells me. Because I can very quickly come up with other conversion questions that aren't in your calculator. Okay? So if we now bother to go through and enter this into the calculator, we would get the answer 10,972.8 centimeters, because that's what my calculator tells me. guaranteed that answer shows up in your multiple choice options. So let's take a quick second to write down some multiple choice options. And actually, I'm going to need that section. So here's some multiple choice options. Option A will be exactly that number, 10,972.8 centimeters. Option B will be 10,968 centimeters. Option C will be 11,000 centimeters. Okay? And you might go through and look at this and say, well, the answer is clearly 10,972.8 because that's what the calculator spit out with the work that Mike has shown. Okay? Unfortunately, that answer is wrong. Okay? The next answer on our list, 10,968 centimeters. Believe it or not, that is a possible answer. Okay? That possible answer appears magically when we go through and set up our conversion in this way. In a slightly shorter calculation, we can get 10,968 centimeters. Okay? Because this was a shorter calculation, this must clearly be right, and unfortunately, no, it is also wrong. Well, that last answer can't possibly be right because it's lost all that information. Okay? This isn't 11,000 centimeters, it's 10,900 and change. Okay? This is where we have to remember, yes, our very favorite, significant digits. And when we go through and look at the number that we were given to start with, 120 yards is only 2 sig figs, which means the answer must be reported to 2 sig figs. Our answer of 11,000 centimeters is actually the correct answer. Okay? A and B are wrong because they don't properly take into consideration sig figs. Okay? So, now that we know the correct answer, let's address what's going on with A and B. Why on earth, depending on how we set up this conversion, do we get two different answers? Well, we get two different answers because of the footnote when dealing with metric and English conversions. Okay? The conversion factors that we used, for instance, this 0.914 meters equal to 1 yard, is not a definition. It has 3 sig figs. Because of that, those measurements can now mesh or mess with our conversions. And if we went back and looked at the previous conversion factor, we'd have to evaluate all of those independent things to see how those sig figs could affect our answer. And because they aren't exact definitions, they're looking at different metric English conversions, we introduce error into our conversion factors. That error can propagate all the way through to a final answer and allow us to see the difference between A and B. Okay? That is a bit irritating and frustrating, but that's the way it works. Okay? That's what our footnote is saying down here. We are assuming 3 sig figs. We did enough of these conversions kind of historically that eventually someone came through and said, this is stupid to have to deal with this, and they went through and changed the length of an inch and a centimeter such that 1 inch by definition is 2.54 centimeters. That one is now an exact measurement and has infinite sig figs. Okay? But virtually every other conversion factor does not have infinite sig figs. It has 3 sig figs. Okay? If I want more sig figs, I have to look up a new conversion factor that shows those extra sig figs. Okay? That's kind of frustrating, but that's the issue on why shifting between English and metric is a bit rough to have to deal with. Okay? So, with that, we can move on to see where this became an issue. Here's just a fun little cartoon meme for us to take a look at. Okay. Yes, I found this on the internet, so no, I can't verify its entire veracity, but it's at least somewhat appropriate. Okay. According to this, the French made a cool tank. The US said they would make it under license, and got the blueprints from France. And of course, the French use the SI system of measurements, and Americans use the American system of measurements, and they don't line up. The amount of trouble it takes to then either do the conversions, okay, or retool a factory from American to metric or metric to American is now beyond the level of reason, and we end up not being able to license each other's stuff, to build each other's stuff. Okay? This is also one of the reasons why we will probably never ever agree on a common unit. Okay? The only way a common unit is going to come about is if one or the other is entirely destroyed. Okay? That would kind of suck for potentially obvious reasons. So, we could come up with more conversion factors or more conversion questions. So you might have seen something like this in a math class. Harry wants to exchange his pennies for dollars. Douglas loves silver things and will only exchange his dollar bills for silver objects. What does Harry have to do to get his pennies converted to dollar bills, and how many dollar bills can he get? Okay? So in this scenario, Harry only has orangey brown materials, so he can't get dollar bills from Douglas. Okay? Whereas in the real world, you might just be, well, Harry's stronger than Douglas, he just beats up Douglas and steals his money. Okay? We aren't there. What we're trying to do is deal with it within the context of our environment. So we have to recognize that Harry will have to exchange his pennies with Sally to get dimes. Once he has dimes, he can then exchange them to Douglas to get dollar bills. And so we have this kind of convoluted system behind where this comes from. And we see this kind of question in math classes. Okay? And these would be, word questions that everybody hated and railed against in math class. Ultimately, these things are setting you up for a system in chemistry or sciences where we have to deal with measurements. They aren't arbitrary numbers that you just punch into a calculator. You have to understand the relationships between those numbers through the units. And while you may be able to do this one in your head, what happens if we switch it? Okay? What if instead of Harry having pennies, he has Snorlaxy and he wants Skittle farts? Okay? The whole system now gets a little bit out of whack. We'd have to deal with different conversion factors. Those conversion factors are confusing to us because who the hell knows what a Snorlaxy is or a Skittle fart? And so coming up with a system to allow us to do these conversions now becomes challenging, and a question that was really straightforward before that you probably did in your head now becomes too difficult to internalize. Okay? This is why we need the process behind how we start. Okay? So again, what are we trying to get? We're trying to get Skittle farts. To get Skittle farts, well, that's way too big of a word, so I'm just going to write SF. He's starting with Snorlaxy, which we'll just call SL. Okay? He has 100 Snorlaxy. He wants to be able to get Skittle farts, so ideally he would convert directly to Skittle farts. However, Douglas is kind of irritating and won't allow that conversion, and instead we must convert the Snorlaxy to dimes first. The Snorlaxy to dime relationship, 10 to 8. Okay? Now that he has dimes, he can convert the dimes to Skittle farts because Douglas will accept those silver things. That conversion gets us our 3 to 1, and we can now enter this into a calculator to come up with a potential solve. The process allows us to do it even though the units make absolutely, utterly no sense. Okay? But the process gets us there. So every time you go through and solve a question, you need to be thinking about what is the process by which we do this. Okay? The rest of these are now examples on conversion processes, or the rest of this kind of slideshow, which is roughly another 20 slides. I'll be nice and we'll talk about those actually in class, again within the context of how we set up these conversions. Okay? So, good luck with your conversions. Start practicing them. Start getting the process nailed down so that you can trust it and that the unit work is shown. If the unit work does not get shown, you will not receive credit for your calculations. Okay? Have a good weekend.